So welcome everyone to NetMaster Benefits of Enabling zERT. We've got Anna and Phil from Broadcom. We've pre-recorded this session, but they are here live. If you want to ask any questions, just let me know and we'll pause the recording and then we can start again.
NetMaster Benefits of Enabling zERT. Hi everybody, thanks for joining. My name is Anna Clayton and I plan to tell you everything you need to know about zERT, what it is, how to set it up, why you should care. Afterwards, my colleague Phil Shane will walk you through the ways NetMaster uses and displays zERT data. So what is zERT? zERT stands for z/OS Encryption Readiness Technology, and it was introduced with z/OS v2r3. v2r3 was introduced in September 2017, so zERT has been around for 6, maybe 7 years. Prior to this, there was no great way, no one-stop shop to gather information about cryptographic protection at a high level, so this is pretty powerful. zERT provides information about the cryptographic network protection of TCP and enterprise extender connections terminating on a z/OS system. It's your window into the way different resources on your mainframe system are encrypted and protected. Using zERT, you have a single source of information to determine cryptographic protection. zERT uses the TCP/IP stack as a collection point and repository for attributes which can be used to determine several things. Number one, which connections are protected and which ones are not. zERT can tell you how the traffic is being protected. zERT recognizes the following cryptographic methods. TLS or SSL is explicitly coded by the application, meaning whoever created or coded the application has to purposely include security protection. ATTLS, where applications are transparently protected by TLS encryption. ATTLS creates a secure connection on behalf of whatever the application is, without the application or the programmer who created it having to be aware or mindful of security at all. This is controlled by a policy, so zERT could be used to help you find omissions or incorrect statements in your policy. Traffic can be protected by IPsec or VPN, where users establish a tunnel at the IP layer into the stack to protect all data coming and going from the resource they're connecting to. So it provides a platform-to-platform encryption. This, by the way, is the one cryptographic protection method involving enterprise extender that zERT recognizes. And finally, traffic can be protected by secure shell using z/OS OpenSSH, providing secure terminal access to z/OS. Another thing zERT can tell you is who the traffic belongs to. Attributes collected by zERT include job name, job ID, and ASID. So if you've got a connection that you expect should be encrypted but it's not, you can find the owner and ask them to take a look at it. Most importantly, the question you can answer using zERT is, do connections configurations adhere to your company's security policy? This information is valuable for determining regulatory compliance and for identifying connections that might need stronger cryptographic protection. As of z/OS v2r5, so a more recent addition and not part of the initial support, zERT allows you to set up what's called policy-based enforcement. This means you can set up a policy to take certain actions based on ports, addresses, cryptographic attributes, things like permitting the connection, terminating the connection, writing a message or detail record automatically based on the cryptographic protection. This means you can create policy statements that say things like, if a connection comes into this range of ports and has TLS 1.0 instead of TLS 1.2 or above, we're going to immediately terminate the connection and write a message to the log. NetMaster recognizes policy-based enforcement actions in which policy is in effect, which Phil will show you in a few moments. zERT records provide quite a bit of information to help you identify the connection, as well as information showing how the connection is protected. To identify the connection, zERT captures information such as address, space ID, and job name, so you can determine where the traffic originated or is bound. zERT also reports on the duration of the connection, start and stop times, incoming and outgoing byte counts, which IP addresses and ports were used, when the traffic became encrypted, and other information just about the connection itself. For traffic with recognized cryptographic protection, zERT also tells you which cryptographic protocols are in use, which algorithms are used, the length of the cryptographic keys, and other statistics about the specific cryptography that is used. zERT gathers data by two methods. The first is stream observation. This is where zERT observes protocol handshakes as they flow over the connection. The other method is collecting data straight from a recognized and supported protocol provider. Examples of these include System SSL, zERT JSSE provider, OpenSSH, and ZOS IPsec support. So now for a comment on the things zERT does not do. zERT doesn't prevent information on unrecognized cryptographic methods. If you've got an application using some unknown or proprietary means of encrypting data, zERT won't recognize it and will report it as not protected. zERT doesn't store keys or passwords of any type. It keeps the key length, but that's all. That said, since zERT gathers so much metadata about how your network is protected, make sure to adequately protect anywhere that you use zERT data. Another thing to note is that when zERT is enabled, it does not retroactively fetch information about connections that existed prior to it being enabled. Data for any connection that is already established when zERT is enabled is not gathered, and as zERT is disabled and re-enabled, any data that had been gathered is discarded and won't be reobtained. zERT also does not report on connections that go through the mainframe. It only observes connections that originate on or terminate at the mainframe. So how does zERT communicate its findings to us? zERT uses SMF type 119 records. There are two subtypes of SMF 119 records that are used by zERT. The first is subtype 11, or zERT connection detail records. These records are gathered through a function known as zERT discovery, so you can think of detail and discovery as synonymous. zERT writes connection detail records on an event basis. We'll go over the data found in these records in a minute. The other subtype of zERT records is zERT summary records, which are gathered through a function known as zERT aggregation. zERT writes summary records not for each individual connection, but for a time interval, and groups connections into a single record based on their server IP address and port and client IP address. NetMaster does not use zERT summary records, only detail records. There are two methods for retrieving zERT records. The records can be queried using SMF and obtained as they are created. The records can also be obtained using the NMI, or Networking Monitoring Interface. The sys-TCP-ER service is used to collect detail records, and the sys-TCP-ES service is used to collect summary records. zERT writes connection detail records for certain events. There are 6 events for which a detail record is written. 10 seconds after a connection initiates, when zERT recognizes a change to the cryptographic protection attributes for a connection for which the connection initiation detail record has already been delivered, and when a connection is terminated. There's also a special short connection termination record that replaces those detail records for a connection that's established and terminates within 10 seconds. This is a way to try to stem the flow of zERT detail records for workloads with short-lived connections, since often when a connection is short, it is part of a series of several short connections. zERT detail records are also written to note when the zERT function itself is enabled or disabled. Here's the format of a zERT connection detail record. The 2 sections at the top in green are always present. They are the TCP/IP identification section and the zERT connection common section. The first gives information about the job, things like the system and sysplex name, stack name, address space name and ID, and user ID. The zERT connection common section gives general details about the connection, such as the crypto protocols used, the IP protocol, the job name, job ID, the date and time of connection events, and the local and remote addresses and ports, and the inbound and outbound byte counts. The next sections in orange are present only if they apply to this connection. These sections are the IP filtering section, the TLS protection section, the SSH protection section, the IPsec protection section, and the X.509 distinguished name section. This last one, which details distinguished names from relevant certificates, is only present if zERT got its information from a protocol provider, not if it's gathering data via stream observation. Each of the orange sections collects protocol-specific details. Now, since these records are built on a connection basis rather than on a protocol basis, you might have 0, 1, or many of the orange sections. For example, if a connection is protected by both TLS and IPsec, and it also meets the criteria for an IP filter rule, you'll have sections related to all 3 of these, all in the same detail record. So now on to zERT summary records. Summary records are newer than detail records and are IBM COM server's response to the fact that you could enable zERT and suddenly see hundreds of thousands or millions of records being created. Some workloads consist of large numbers of frequent, short-lived connections, and even with the 10-second delay and the short connection termination record, this adds up to a lot of SMF traffic, which is not ideal in some environments. The COM server developed a new function called zERT aggregation that writes a different subtype of SMF record, SMF119 subtype 12, or zERT summary record, that summarizes the repetitive use of security sessions over time. zERT summary records show how the communication between a client and server, based on the server's address and port and the client's IP address, is protected over time. This behaves the same regardless of whether the local ZOS system is the client or the server. This is an interval-based protocol rather than an event-driven protocol, so at the end of each customizable SMF interval, a summary record is written for each security session that was active during that time. So rather than the steady fire hose of detail records, at the end of your SMF interval, whether it's 15 minutes, an hour, 24 hours, you will get a batch of records telling you what happened during the previous window. So here's what a summary record looks like. Again, there are the TCP/IP identification section and the zERT summary common section in green that are always present. The fields found in these sections have some commonalities with detail records, but some of the fields are different. For example, rather than being dates and times of connections being established and terminated, because these activities could have happened many times during the interval, the data that we see is things like connection counts at the start and end of the interval, and byte counts at the start and end of the interval. Following in the blue sections are protocol-specific attributes, TLS, SSH, and IPsec. The difference here is that each summary record will have only one of these sections. If you have a connection that was protected by more than one method, you'll get more than one summary record to give you all the details. Finally, the X.509 distinguished name section contains information about distinguished names from relevant certificates, which are available if the zERT data was gathered from a recognized protocol provider. So now for the most important question, why do you or why should you care? First and foremost, zERT is able to be used to ensure regulatory compliance. As you all know, GDPR, or General Data Protection Regulation, was published in 2016 to establish regulations on data protection and privacy in the European Union. Remember, zERT showed up in ZOS v2.r3 within a few months or a year of the passing of GDPR. So our good friends at IBM recognized that due to these new regulations, corporations were going to need to be able to verify and prove they've complied with all regulations related to data privacy. Along with this comes internal auditing. We need a method to gather security-related data to present to internal auditing teams to ensure we are protecting data correctly and completely. Next, zERT can be used to easily detect vulnerabilities. You can use zERT to generate a list of all connections that are not protected by recognized cryptographic methods and correct those as required. You can also use zERT to list all connections protected by a cryptographic method that has a known vulnerability. For example, say a vulnerability was found that affects TLS 1.3 but does not affect TLS 1.2. You could use zERT to quickly and easily pinpoint all connections currently using TLS 1.3 to switch them over to a different protocol until the vulnerability was addressed. Finally, zERT provides a more complete view of your network, another facet of your mainframe operations. As people who like to crunch data looking for trends, knowing everything about our systems, zERT provides an easy way to shed light on all you'd ever want to know about network encryption. Sounds good, right? So how do you set up zERT and use it? From the ZOS perspective, there are 3 steps required to enable zERT. First, you have to make sure you have enabled SMF119 records in your SMF PRM PROMLab member. You've likely already got that done. Next, you need to enable zERT monitoring in your TCP/IP profile dataset. You do this by changing the value of the global config statement in the dataset. To enable, you indicate the keyword zERT. Finally, you need to tell zERT what to do with the records. If you want the records to go to the SMF datasets or log stream, specify SMF config type 119 zERT detail. If you want the records to be available for the real-time NMI, specify NetMonitor zERT service. And if you want records available to both services, use both commands. NetMaster currently uses both SMFconfig and NetMonitor to most efficiently capture all data about all connections. There are similar commands to enable and record zERT summary records. We'll care more about those if NetMaster start utilizing summary records.
Recently, we added the capability to capture zERT records exclusively through the network management interface. This was a direct request from some of our customers who are looking to better manage the potentially large number of zERT records that could accumulate. If you're interested in taking advantage of this capability, then you can omit the SMFconfig Type 119 zERT detail statement from your TCP/IP profile and add the PA zERT SMF NMI parameter to your SSI sysyn member and set the value to yes. For more information, you can reference our release notes for this feature or post any questions you have in the chat.
Once you've completed the configuration steps, there are a few things you can do to make sure zERT is properly configured. The first is through the netstatconfig command, which can be entered directly in the NetMaster command line. There are 3 sections you'll look for in this output. The first is in the SMF parameters under the Type 119 label. You should see that the zERT detail field is set to yes. Further down in the global configuration section, you'll see a zERT label, which should also have the value of yes. And finally, a little further in the network monitoring configuration section, you should see a zERT serve label with a value of yes.
If you have configured the zERT records to be obtained exclusively through the NMI, then the zERT fields of your Type 119 SMF parameters will have a value of no.
Another way to verify your zERT configuration is correct is through NetMaster itself through our $syspro nmipdiag command. In the section titled Checking IBM TCP/IP SMF Configuration, we will tell you what you've got set up and display a warning for services that aren't set up as expected. So now that you know more about zERT than you probably ever really wanted to know, I'll pass the mic over to Phil, and he'll go over how NetMaster uses zERT data.
Thanks, Anna. Yeah, so when we talk about how NetMaster utilizes zERT data, NetMaster is a very large product with many different pieces to it and many different functionalities. So I like to break it down into a couple distinct pieces. The first way NetMaster can utilize zERT data is through diagnostics. So these are things like real-time diagnostic data that's being captured by the packet analyzer and being correlated with zERT SMF records so that we can get real-time information about our security in our network. Pages you might see this would be in our list connections, where we can list all the connections in your network. And then we can use our extensive search criteria there to narrow down on what exactly we're trying to look for. Next, we have our historical section. These are things like IP history. We can go back in time and sort of look at what the security of our network has been like over time. And again, we have extensive search criteria there to sort through all of those detailed historical records, because there can be quite a lot of them sometimes. So we really need to be able to filter in on those. Next, we have our summary views. So these would be things like our security visibility across the various stacks that you might have running. The best way you could utilize looking at these would be through our web portal or our 3270 interface. We have our web portal, which is a newer offering to display a lot of our mainframe data in the web. It's a very useful tool and can really help get a lot of security information in the web view. Next, we have our real-time monitoring. These would be things like our event detectors, and an example of that would be our TCP security level enhanced event detector. So this is going to be monitoring connections in your network, evaluating them against a given set of criteria, and then alerting you when an event comes in that matches that criteria. So we're going to do a bit deeper dive into each sections of these. So here we're looking at TCP connection list criteria. So this is, we see a whole lot of different criteria here that we can filter all the connections currently in our network. They are very useful, but we're looking at zERT data here. So what we can utilize zERT data for is the secured field, yes or no. So we can filter immediately based on if a connection is using a secure protocol. So if we filter based on that, we can come to this view. In here, we can see the list of connections. We can see if they're secure, and then we can see what level they are secured to. So if we were on TLS 1.2, TLS 1.3, we could see SSH here as well. This is just a at-a-glance view of all of the security in your network per connection. And again, we could filter that however we see fit to get a smaller list. So next, we also are now drilled into a specific connection. We can see for these specific connections, we can see the local end role. So what role does the server, or what role does the connection play? We can see in this case it's a server, or it could also be a client. We can also see the security level. Again, we saw that on the other screen as well, but we can see that again here. And then we can see the cipher that's being used on this specific connection. That can give us a lot of information, just more detailed information about the security attributes of this connection. We can also get a lot of certificate information. Here we can see various attributes about the certificates being used on a specific connection. This specific connection has both a server certificate and a client certificate. With these server certificates, it's important that we keep these up to date. Otherwise, our applications might show as insecure because they don't have a valid certificate. Some information that zERT, or that we expose from zERT in here would be things like the expiry time, and then as well as the serial number. Say you want to make sure that a specific certificate is being used for a specific connection, you can verify that in here. And then we also, if applicable, we show the client certificates as well for a specific connection. So here's some more detailed zERT information for specific connections. Here we can see the zERT policy-based enforcement that Anna talked a bit about earlier. We can see for a specific connection if there is a policy enabled for it, and then we can see which rule is being applied. In this case, it's the TLS rule. And then we can also see what action is being taken on this connection. In this case, it's just to silently allow the connection through, but you can set up a number of actions to take based on the various criteria that the connection has. So these are a lot of fields, and they can be a little complex sometimes. We don't expect you to memorize all of these, of course. So we do provide in panel help. You can press F1 and you'll see a list of all of the fields for a specific panel. And we show all of these zERT data here as well. We give a brief description about what each field is and what you might find from it. Of course, we also have our tech docs. They're out there published online, a lot of information there as well. So what we can see here in this view is going to be the web portal view. I mentioned that a little bit ago. It's our web-based offering to display NetMaster information. What we can see here is a specific part of our web portal that displays the zERT data. In this case, we're looking at TLS information. And we're going to step through a couple of these fields and discuss them a little bit more in detail. The first field that we have here is the protocol version. Again, we looked at this a bit earlier. It just shows the version we're on. So next we have the source for the zERT data. Anna mentioned a bit ago about the two different ways that zERT can get its data, either through stream observation or through the cryptographic protocol providers. That information we also display here. Next, if we jump ahead a few fields, we can see the session ID. This would be the session ID that's used if you were looking at zERT summary records to correlate different sessions, different security sessions. So you want to make sure if your security sessions are being appropriately summarized by zERT. Next, we can see the protocol provider. Again, this just in this case is a stream observation, so we don't see any protocol provider here. But if we were using a protocol provider, we would see that here. Anna mentions like zERT JSSE or System SSL, things like that. So I mentioned that all of these fields are able to be seen in our 3270 interface, and they come from zERT data. However, this one is sort of exclusive to the web portal. Basically, what this does is it sort of summarizes the cipher information that we have for a specific connection, and then we make a determination on the overall security level of that specific cipher. So when we go to this last field here, this is the security level field. I mentioned earlier that all of these fields are available in our 3270 interface, except this one. This one is exclusive to the web portal. Basically, what this field is it summarizes the cipher for this specific connection, and we will display an overall security level for that connection or for that cipher, displaying if it's a weak cipher or a strong cipher. The way we obtain this information is by referencing a third party that summarizes industry research and published white papers by the Internet Engineering Task Force. We sort of reference them in the research they've done and display a summarized security level in this field here. So yeah, on this next slide, we see here that we also provide SSH information. It's not just TLS information that we display in the web portal. I'm not going to walk through all of these fields, but some of them that might be of value are the SSH subcomponent. So this would be whether this connection is an SSH daemon or if it's the client or things like that. It'll display what role this connection is playing in the SSH protocol. So while HTTLS information isn't directly related to zERT, it's also an important bit of security that I just wanted to highlight that NetMaster's display some information for. Specifically here, we can see the HTTLS policy that exists for a specific connection, and then we can see the security status. So we can see if it's secured by an HTTLS policy. We can see if the handshake is in process, things like that here. And then also HTTLS, we can also view some security level data, the ciphers. We can also see the zERT policy-based enforcement information here as well. But we also display a whole host of HTTLS information. Next, we can talk about how NetMaster utilizes zERT data and Enterprise Extender. We can use NetMaster to broadly monitor our Enterprise Extender connections and the security status for those connections. We can see detailed security information per specific Enterprise Extender connection as well. It's important to monitor these Enterprise Extender connections because oftentimes they come from outdated applications that might not be particularly up to date on their latest security standards, typically originating from more legacy-like applications. So it's important to monitor these connections as well, because these could be potentially vulnerable to just outdated security practices. So in NetMaster here, we can see on this top left screenshot, we can see a list of the connections for in our network for Enterprise Extender. And then on the right-hand side, we can see the highlighted column for secure, yes or no. Again, this will just display at a glance if we have a secured Enterprise Extender connection. That's just sort of vague, though. If we want some more detailed information about the security for that connection, we can drill down into that, and that's what we see on the right here. We can see a list of the IPE tunnel details as well as the IPsec tunnel details for that connection. This displays a whole host of various security attributes related to those tunnels and how we sort of secure connections with Enterprise Extender. Again, this is all exposed via zERT. So this information is great, but let's zoom out a little and think, how can we relate this to the real world, right? We want to make sure, that there's a lot of information here, but how can we actually use this information? Well, say, for example, we're looking through all of our Enterprise Extender traffic, and we want to make sure that we're up to date with the latest set of security guidelines that are published by our internal auditors. What we can do is we can look at the summary of connections. Obviously, if one is not secure, we can immediately flag that one. But if they are secure, say we want to look at the specific information. We can look at this information here and say we're evaluating the random function for that IPE tunnel details. We can look at the random function for the specific IPE tunnel details we're looking at here. We can see that it's using the HMAC SHA-1 algorithm for the random function. So we want to verify this is up to date with our latest security standards. Our security standards will reference the NIST special publications on the security strengths of our pseudo-random functions. So we can see here, we look at the handy-dandy chart that they provide us, and we can see here the recommended algorithms, the legacy algorithms, and the expected algorithms. We can see here that HMAC SHA-1 is listed as a legacy algorithm, so we would want to address that, and we can see here that this specific connection might not be up to date with the latest security standards. So this is just a way we can utilize zERT data to actually verify that we are compliant with various standards that exist for our industry. Shifting gears a little bit, now we're going to talk a bit about the IP history and sort of the historical context that NetMaster can provide for zERT. So basically what this does is it looks at historical connections in the last 7 days, and we can sort on that data based on various security attributes that exist for it. We can specify various times, right? So we can specify a from time, to time, from date, to date, just so we can focus in a specific time period of connections we're looking for. And then towards the bottom there, we can see some various filters that we have. We can filter based on secured connections. We can filter based on what protocols they were using, what protocol versions they were using, and then what ciphers they were using. And that's what we see here in this example. We're going to look through the past 7 days of data here and for that specified time frame and look at what connections were secured with this given cipher. This can be really useful in times where, say, we have a deprecated cipher that we're getting rid of out of our network. We want to make sure that we've gotten it out of all of our policies. We can look back at the previous 7 days to make sure that we really have eliminated all the use cases for that specific cipher. Next, we can also look at the security visibility across various stacks that you might have running. So what we can see here is what we call our encryption summary view. What this does is it summarizes all of these secured connections based on a specific entity. In this case, we're looking at home address. So what this will look at is all the current connections in our network originating from this home address. And then we can see a breakdown of how many of those are secure connections. And then we can see a breakdown of which exact version of security protocol they are using. This can, again, provide a really useful at-a-glance view of the security status for a specific entity. We can see the ones in blue are home addresses that have no secure connections, just sort of highlighting that, hey, these home addresses have no secure connections. So I mentioned you can summarize them by various entities, and that was what we see here on the bottom. In addition to home address, we can also summarize by things like task name, hosts, ports. We can specify different entities that exist summarized by them, and that's what we'll see here as well. And then we can also just get a high-level overview of all the connections in our network and see which ones are secure and not. In addition, we can also get a sort of historical perspective, and so we can see a list of the summary totals for a specific entity. In here, we can see the total number of secured connections since NetMaster was last started. We can see the total number of reset connections. So this would be resets based on policy-based enforcement. So if you have policy-based enforcement running, you can see here which connections were reset by that. And then we can see the total number of connections. And then we summarize it again by task name or whatever other entity you might have specified. So we've been sort of taking a bit of a reactive approach when it comes to looking at zERT data, but we can also take a more proactive approach in monitoring the connections within our network. What we can do here is we can set up an event detector. So what event detectors are in NetMaster, we can look at all of the incoming connections or all of the connections in our network and evaluate them against a given set of criteria. We have a whole lot of event detectors, but the one that we'll be looking at specifically here is the TCP security level event detector. So on the left here, what we can see is the screenshot of us defining a new event detector for NetMaster, the security level enhanced event detector. What this is, we can specify various attributes like protocol name, cipher code, cipher suite, and then we can get as specific or as generic as we want with the task names, local hosts, remote hosts, and ports as well. So we can specify a, say, given protocol like TLS 1.1. You know, it's a more outdated protocol. We want to make sure that it's not being used in our network. So we can specify that protocol here. And if a connection comes into our network, an event will be triggered, and we can do various things with that event. We can do things like forwarding an alert off to your alert management product. We can display the alert in NetMaster's own alert summary view. We can also take a number of automated actions, things like dropping a connection. We can also run custom JCL or custom REX procedures. You can run various NetMaster commands or ZOS commands themselves. So there's a lot of functionality that we can do here based on a given event if it hits our criteria. And then on the right here, I'm just highlighting that you can also generate an email, so you'll be notified, you know, if a connection comes in that matches your criteria. You could take, you know, proactive action on that connection. Another event detector that I wanted to highlight is our certificate expiry time event detector. So what this is going to be doing is looking at the connections incoming into your network and we'll evaluate the certificates for those connections. And then if a certificate is expiring in a predetermined time frame, here we can see it's 7 to 999 days, an event will be triggered and you can alert yourself that, hey, my certificate's expiring, I should probably go update that. Because we want to be proactive in our certificate management. We really don't want a certificate to expire. So again, I said we can specify based on days to expiry. We can also specify whether we want to look at just client certificates or just server certificates. And then we can specify if we want it to be a local or remote host, so where the connection is originating from. And then we can also specify, you know, task names, local ports, and remote hosts. So that's what we have for you today. Thanks for joining our session. I hope you learned a lot about zERT. Please share your feedback on today's session. You can complete a survey for this session by clicking the survey option on the screen for this session. And of course, please feel free to stick around. We'd love to have a chat with you about zERT, any suggestions you have for us, any problems you're having with zERT. Again, it's an open forum Q&A right after this session. Please join us for a discussion about zERT.
Okay, are there any questions, queries for either Phil or Anna?
Just wanted to say thanks to everybody for joining this afternoon.
Yeah, likewise. Thanks for coming.
Thanks, everybody. If there are no questions, then we'll end the session here. Thank you.